Okay, good afternoon all. We are going to start with your S4 lab, especially your circuit lab. We are going to start with the Orcad cadence tool, Orcad. Then how to simulate, how to create a project, how to get the output, how to analyze the output. These are the goals with us. So I think you all of them are already installed with the cadence tool. We already provided the details how to install and already provided the setup file, or otherwise you would get the file from the internet by go to the cadence website. The you are installed or you are going to install 16.6 version of the students version or cadence students version. If anybody or all of them installed the software, then you can see lot of other tools are installed within your computer. If you go to the start button in the cadence folder, then you can see lot of tools. So you need to know which is our correct tool, which is the correct tool that we are going to simulate our circuits. So you already familiar with the LT Spice. This is also a Spice tool. Spice is the basic behind this all. So if you have the lab correct lab in the college, then you are going to do these all things within your hands. But now this pandemic situation, so we are decided to do this all in virtual way, or otherwise the professional companies are also using the analysis way by Orcad, LT Spice or Spice, then Protistina, and a lot of tools are available. Orcad is the one of the familiar company and very useful company and a professional tool using in the circuit design, PCB design, schematic editing, etc. etc. So it's a major tool in the industry and also a industry leading tool. So you need to know how to take the tool, how to create a new project, how to draw the circuit, how to simulate. We are going to start. So you first of all start, then all programs. Actually, I'm using Windows 7. It's an old version. If you go with your computer, maybe it is in computer or laptop, it is in Windows 10 version. So as per your version, which version you are using, Microsoft tool or the Windows tool, so you go to with the same way. As already know, because you all of them are very familiar with the modern technologies and the computer technology, so we don't need to explain how to take a program from the computer. So I'm not going to that. Just in our way or in my limitations, I'm showing with the Windows 7. So start, go to Cadence, then go to Orcad CIS Lite. Orcad C. Lot of other tools about Orcad, Cadence Help, Orcad Capture, Violi, PSpice AD Lite, PSpice Advanced, and many more with this. Our tool is Orcad Capture CIS Lite. Just click. Then you will get an interface like this. Then maximize. As we go with the any kind of software tool, there is a menu window and version window. This is the details showing the version of Orcad Capture CES latest 16.6. 16.6 is actually a student's version, so you don't need to install any kind of license or something. But some limitations are already with this tool. We can go with the higher end simulations and the design. So in experimental way as a student, you can use this in faithful way. So this is the first phase of this front end of this tool. Then if you go with then how to first of all how to create a project. Go to file, new, click new project. Then first of all you give the name of the your project. Actually, if you go to the interface page, you can't see any anymore because most of the large number of icons are here. All are in the invisible way or hidden way. All are hide. So if you go to this starting with your project and the simulation work, then all of them become active and you can use as per the requirement of that. This is another window you can use here. This is the different kinds of tools and the shortcuts, and lot of many more is available with this Orcad version. So this is the way I can show you once more. File. Then before that, you just go to your computer, then take the form local disk D or E or any as per your, then open it, then create a folder named Cadence. This is my way I am doing this. As per your interest, you can give different name, folder name different as per your requirement. You can give the different names, because I am provided here Cadence. Then open it. I did a circuit in the integrator, created another folder and renamed as integrator. This much I did in advance. You can also follow the steps. Just to go to any of your local disk, create a folder named Cadence, then open the folder and create with a new folder, create a new folder and a name integrator differentiator or any experiment. If you go with this kind of way, then every experiment is individually located in the folder. Otherwise, if you simply select that Cadence folder only, you are going to do different kind of simulations and project, and every project will listed in a assorted way. So so if you go create a different folder for different experiments, then that will be easy to guide in with your future preference. That's why I'm asking you to create a new folder inside the Cadence folder with the name of your experiments. Otherwise, if you wish to do simply, then as per your choice, you can do anything. No problem. Then close it. Then go to File, New, New Project. Then give the project name as Integrator. Integrator. Then OK. Then create a blank project. Press OK. Now you can see some of the icons are here active. Your tool window is also active right now. Then what are the components that we need to do the integrator? That's only a resistor and a capacitor. In integrator, resistor is the input and the capacitor is the output. So then how to take the tools, because if you go to right click place tools are available, but in case of simulation you just go to place p space components, take resistor first, resistor or capacitor first, then left click. If you click more components will be added to the, then right click end mode or press escape. Once again select all. I'm going to delete place p space components. Don't go to any other way, because lot of placements are available. If you go to the schematic capture or the PCB design way, other placement modes are available, but with the help of that components we can't go to simulation. In order to go simulation, we must need to take the p space component, generic components. If you go to the placement component, p space ground, capacitor, diode, inductor, resistor, and the digital discrete something, these are the basic components in a spice way, simulation way. So first of all, you can go to resistor, make click here, then that will be placed the press escape or right click and go. Then next component is place component capacitor. Then actually integrator, we need to, as per our convenience, we need to rotate it, plus press the R button, R for real, R button in your keyboard, then it will be rotated. If you need to zoom this, press the zoom button. Then these are the two components actually in your integrator, that is one resistor and a capacitor only. Then another one we need is a ground. After the drawing the circuit, we need to connect with the ground. We need to first then go to here, click here, place wire, then click here. It's connected right now. Now this most of our connections are over. Then this is the integrator circuit, only a resistor and a capacitor. The next one we need to connect it as a ground. Go to place ground, select the 0 CAP sim cap sim ground. This is the ground, plus OK. Then ground symbol will appear here, plus here. Then escape. Press escape to escape from the current selection, because if you are going to select something here, the ORCAD will remember that. If you select a resistor, then press here everywhere. How many press are there? That much of resistors are available. So in order to escape from the current selection mode, you need to press right click or end mode, or press escape in your keyboard. Then we are going to connect to the ground. Click here, click here. Now the ground is connected. Then the another component that we need is the signal source. That is, the input to the integrator circuit is the square wave. Then what will be the output that we can see. So go to then place, go to next one. Already capacitor and resistor we are placed. Then source, we need a source, a independent source. Press here, just wait. So you can see another window with with the heading as independent source, pulse sine DC exponential FM members 3 plus voltage current waveforms. So here which form square voltage V1. Here if you go to with the graph shown by the software itself, square wave with the V1 V2, from that what will be the requirement of the voltage. Here I am going V1 as plus 5 volt, just give 5, then V2 as minus 5 volt, minus 5, then delay is 0, rise time is 10 nanosecond, fall time is 10 nanosecond. You don't need to edit anything here, or otherwise if you have any special purpose, then only you can change this. AC 0, DC 0. Total time period also, if 10 microsecond is very small time period for your simulation purpose, so you need to change this only. This is 10 millisecond. 10 or 1 millisecond. Just we can give 1 millisecond here. Just put a 1 amp. Then place. Just click here. Then you can see the voltage sources here. Then we also need to wire this. Then go to connect. Click here. Then click here. Click here. Click here. Now our connections are over. This much only. Then if you modify, you can click and drag as for your requirement. Okay. Now we need to rename. As for our design already provided by the PDF by your lecture. You have a lot of experience with the details are provided early. So as per the design, the value of resistor is 5.6K. Just go to there, click here and double click. Then change it as 5.6K. 5.6K. Then OK. Now it is 5.6K. This is a 0.1 microfarad capacitor. N indicates nano, then 0.1 microfarad. Micro is U here, letter U. Then okay. Now it is 1 microfarad and 5.6K resistor. Now the components are okay. Then signal sources are okay. Ground is okay. Your connections is now just you need to connect with the probes. As for when we are doing lab in our practical lab or in college, what will we do after the connections? We are going to connect with the CRO. So you need to select the probe and connect here. Just click it, select and click it. Then connect here, then press escape. You also need to name this net. If you are going to the schematic design, the connections are called net. This is one net, this is another net, this is another net, this is another net, this is how many wires are there? These wires are called net, net, net. So for our convenient purposes, if we in case of resistor and the integrator circuit, only two components are here, so no more confusions with the connections. If you go with the large components like a power amplifier or any other large digital or analog circuits, lot of nets are there. We need to analyze which is the net, which is net, which net is going to where. So these are very important things. So we need to label the net. In order to label the net, or rename the net. Now the net name is N00200 is the net name. This is the N00156 is the name. So this is very difficult to find in your simulation way. So we need to rename this net. For in order to rename, there is a tool is a place net alias. Just click here. Then a net alias window will open. Then type here v v in v in. Just put OK. Then net alias name with the window will appear here. Just connect here and click. Now the net name is changed to v in. You see v in name equal to v in. Another we need to do is v out. That type here v out. Then press OK. Attach with the net. Now now enter mode. Then if you go to that net, then the output name become v out. Then this is become v in. Then next, then p space new simulation. We are going to simulate this. Then only we can see the output waveform. What will be the, maybe it is correct or not. We can analyze with the, if there are any problem, then you can see with the simulation only. So you go to new simulation profile, give a name as integrator create. Then the simulation profile will open. This is the simulation setting for integrated. Select general, leave it, and is your name and folder directories, etc. will be listed here. Then go to analysis. If you pop up this time domain or transient response, DCC, PCC, bias pointer, we are select time domain or transient. General settings, leave as it is. Then don't go to configuration option, data collection pro window. That's not related with a simple this simple experience. If you go to the more complicated experience, this all we need to edit. Here we give into runtime because time is the main factor here in any signal. Time versus time is related with the frequency, and voltage is also an independent thing. So as per the integrated design, runtime you give to 10, give 5 millisecond, 5 ms, or don't give capital letter, small letter, 5 ms. Second is an option, so give 5 milli. Then start saving data for 0 because from the starting time also there's a don't give step size. Only then apply, press OK. You need to connect the probe, then just play. You see your output is ready with this simulation schematic integrator p space simulation window is showing. We provided 5 volt square wave, 5 plus 5, this is nearly total 10 volt is provided, 5 volt up and minus 5 volt lower. Then see this is the 0. If you give square wave to the integrator, then you will get a sawtooth in the output. This is showing actually the output voltage to when we give a 10 volt, nearly a 10 volt if we give, then the output will be reduced in integrator, as we already know. And in your theoretical class you are already studied the output of the integrator is low as compared, very low as compared with the input. If you go to the differentiator, then the output is very high with the comparing with the input. Input is in case in differentiator, in output is very high, and in comparing with the input. In case of integrator, input is high and output is very low, and the output is in sawtooth nature. This is the green signal is the this green nature signal is the output waveform is a sawtooth in nature. Only provided 5 millisecond. That's means 5 square waves of 5 number of signals are provided here. If you give 5, 10, any as per your choice, you can give. And in order to give, this is the plot waveform. Different colors are provided for this is the red for input and green for output. If you need to give more plot, then right click, add plot, then a new window with the selection pan will be available in the existing window. then right click, add trace. These are the listings of related with the integrated simple circuit, that is C1, C11, R1, R11, V1, V11, and etc. etc. From that, if you actually our output and input are listed in the output window waveform, output window. If you need to more add one more analysis, or if you need to add as per manually, just go to Vin, then click OK. You can see the input waveform. Then right click, delete. ഓക്കെ, ഇതിൻ്റെ ബാക്കി തിയറിറ്റിക്കൽ പാർട്ടൊന്നും പറയുന്നില്ല, കാര്യം തിയറിറ്റിക്കൽ ക്ലാസ് നിങ്ങൾ ഇത്രയേ ഉള്ളൂ. നമുക്ക് ഇതിനകത്ത് സിമുലേഷനുമായിട്ട് ബന്ധപ്പെട്ട് നിങ്ങളുടെ വേവ് ഫോം, അതായത് നിങ്ങളുടെ ഇൻറ്റഗ്രേറ്റർ എന്ന് പറയുന്ന സർക്യൂട്ട് നിങ്ങൾക്ക് ചെയ്തെടുക്കാനുള്ള കാര്യങ്ങൾ ഇത്രയേ ഉള്ളൂ. ഈ വേവ് ഫോം നോക്കുക, സ്ക്വയർ വേവ് കൊടുക്കുന്നുണ്ടോ, ഔട്ട്പുട്ട് കിട്ടുന്നുണ്ടോ എന്ന് നോക്കുക, ട്രയാങ്കിൾ സോറ്റൂത്ത് ആണോ കിട്ടുന്നത്, അതിൻ്റെ കൊടുത്ത ടൈം വേരിലും ഇൻപുട്ട് ഔട്ട്പുട്ട് തമ്മിലുള്ള വാല്യൂ റിലേഷൻഷിപ്പ് ഒക്കെ നോക്കുക. ഇത്ര കാര്യങ്ങൾ ഇപ്പോൾ നിലവിലുള്ളൂ. ഇപ്പോൾ അടുത്ത നമ്മൾ ഇനി ഡിഫറൻഷ്യേറ്റർ ചെയ്യുമ്പോൾ, അല്ലെങ്കിൽ അടുത്ത സർക്യൂട്ടുകളിലേക്ക് വരുമ്പോൾ കൂടുതൽ അനാലിസിസും കാര്യങ്ങളും ഒക്കെ പഠിക്കും. അപ്പം നമുക്ക് അതിനെപ്പറ്റി കൂടുതൽ പോകാം. ഇപ്പം നിങ്ങൾ ഇതെല്ലാവരും ചെയ്ത് നോക്കുക. ഡിഫറൻഷ്യേറ്റർ എന്ന് പറഞ്ഞ സർക്യൂട്ട് നിങ്ങൾ തന്നെ ചെയ്യുക. ചെയ്ത ശേഷം ഞങ്ങളോട് അതിൻ്റെ ഔട്ട്പുട്ട് വേവ് ഫോം നിങ്ങൾ ഷെയർ ചെയ്യുക. ഓക്കെ, താങ്ക് യു.